It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other, where you put your knowledge to test
and battle it out with the best.
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Mallisham Devasane, I'm working as an educator on Unacademy. In this session, I'll be discussing about graph theory, where this is the second session on graph theory in the Sankal batch, and we will have one more session on graph theory. If you look at the previous session, we have learned the types of simple graphs, like a path graph, cycle graph, complete graph, regular graph, bipartite graph, and many graphs we have seen. In this session, I'll be focusing on connectivity of the graph, and also depends on the time, independent set, covering set, as well as matching of the graph. Yeah. So good morning everyone. Ayushi, yes, good morning. I'm fine. Ayushi. Sneha, good morning. Yeah. Anuj, good morning. Lavjit, good morning. Sneha, Vikas, Mega, Ashish, yeah, Umesh, good morning. Yeah, good morning everyone, guys. Okay, this is the complete schedule of discrete mathematics. We are at this place and we have 2 more days to complete the 4th subject successfully. And we have started this Sankal batch, like TOC, compiler design, including C programming. After completion of these 3, we have started discrete mathematics, and we are also about to complete. Now soon, today we are going to announce what we have for you from the 1st Feb, because we are completing the batch where you have the minimum knowledge or important concepts which are required for gate. You learn something, but if you don't revise and practice, is it really worthy of any learning? Yes. So for fulfilling that kind of strategy, we are coming to the live today. Please attend the live session, which is really going to help you for the coming days. And we are going to have a plan. We are already planned something for you, and we will release. We will announce today, so that please follow the next upcoming plan. It will benefit for you who are facing the GATE 2021. And today we are going to come to the live. We will talk about what we are going to do something for you. Yes. Yeah. Good morning, everyone. If I miss, and please like the session if you are just joined now. Fine. And if you want to know about me and my past, you have complete details on my profile. And if you want to look at my favorite subjects like TOC, CD and many other subjects, but as an educator, I can't take all of them. There is a much involvement on each topic that we deliver, and we just don't teach. We will make you to understand the concept. So that is the difference. Teaching, mostly everybody may do it, but when it comes to the understanding, whether you may like my teaching style or not, but the concept that I deliver, you will definitely understand, because I interact with you. Every doubt that you ask, I will take care of that. So you will be connected to the class most of the time. Yeah. Thank you, Ashish. It's all because of your effort. My effort is only to make you understand, but your effort is you are continuously following my classes, and you are learning, you are asking the doubts, you are involving in the content that makes you to perform well. So performance in any subject doesn't come on a single day, which comes by the time where you have to learn, and you have to create your doubts, and you have to clarify them, and you must practice and revise. Then you will get a confidence, and also you will enjoy a lot in answering the questions. Yes. And as you are preparing for GATE 2021, so these days are going to be very important for you. That is the reason from maybe possibly from today, I will be active on every place like YouTube, special class, and you will be watching every day from today. So I just promising you that till GATE exam, I'm going to make you revise and practice many things that you need for the GATE exam. Okay. Whenever I announce the schedule for the special classes, you may attend on Unacademy too. And this is my profile. In case if you are not following me, please visit this profile and also click on follow. In case if you are very new to Unacademy, you might require a referral code to unlock the free plan. So you may use DEVALIVE. And after attending free classes, if you feel that you need to learn all subjects in systematically, and you want to prepare seriously for GATE 2022 or 2023, you may use this code also for getting the subscription on Unacademy, which gives you 10% discount on Unacademy. Obviously, you can use any referral code, which all codes are same. Only that is you're following my classes, so you may use my referral code to learn everything from Unacademy. Yeah, this is the batch which is started on 18th Jan, and you are going to have many surprises on Unacademy and many faces that you are going to see on coming batches, and you can use DEVALIVE referral code. And this is only the first batch, but many batches are going to come. In case you have not joined this batch, you can take a decision and you can start learning from this batch. And it's not you are not paying for the batch wise, you are paying for the plans for months or years. So in this year, if we release 12 batches, you can attend every batch, or you can attend any batch that you like. It is your choice, but that is what unlimited access to the content on Unacademy. It's just like a Netflix. Okay, don't assume that you are only eligible for this batch. You can attend every batch. Right, you will have so many batches coming soon, but start early in your preparation so that you will have much confidence at the end. Yeah, this is what we have. I think right now the Combined Networks is going on. I think Up to this might be one class more left. Discrete mathematics is going for 2 more days. Yeah, we have Unacademy learning app. You can use mobile to install. Go to Play Store and search for Unacademy learning app and install it. You can watch all videos using mobile. Yeah, plus you have all structured courses, and you will have top educators in batches. Every batch that we launch, it's absolutely free inside, so only you need to decide which subscription you need to take and how many months, how many years. So in that duration, you can access to any batch or any course, and all classes are live interactive. In case you miss, you have available recorded classes, so you can watch recorded too. But we always prefer to attend live classes. That is the reason that plus courses are very popular on Unacademy. And you will have every course, weekly test, doubt solving, and courses will be launched separately for English and Hindi. So in computer science, if anybody feeling that you don't have English conversation, you will be having the full-fledged people that are joined RBR. You know that he delivers everything in English, and also he knows Hindi and interacts well. Like, you have 1 more or 2 more surprises are going to come soon, and you will enjoy a lot in CS than any other place. So believe my words, and computer science is going to rock on Unacademy on this year. So please join Plus or Iconic, which is definitely going to benefit you. And Iconic, you will have all benefits of Plus, and you will have so much of interaction with the coach, and you can interact with every educator. You will have separate material, and all these benefits are happening on Unacademy. So choose as per your requirement. If you have decided for the Plus, we always recommend to go for 2 years. In case if you are planning for 1 year or 1.5 year, choose as per your requirement. But it is all same. All these plans are same. You can access any content in that duration. You are eligible for every course that we launch, every batch we launch. You can go to any educator, any course, but only you decide months. My code is not required to use. You can use any referral code. All equal referral codes are same. But if you are following my classes, this will benefit my army is going to increase on Unacademy. That's only. So you may use DEVALIVE if you are following my classes, but I recommend to use anybody referral code, any referral code from my team or any team. But if you are following our classes, and you may use our referral code to get the benefit from both sides. Yeah, Iconic, you have so many good plans like 1 year, 2 year. 2 years plan, you will have 66,600. Okay, and recently we have started a placement batch, which is a placement programming is different, where it started on 26th Jan. Where what is the benefit you have here? Code Chef certification, unlimited access to current content, and that whoever whoever participating in this batch, they will be eligible to crack top companies. So that's going to be beneficial from this kind of placement batch. And what are other benefits? You will have teaching assistants. They will help you to clear your doubts, to guide you. That is one more advantage. So this is like a combo subscription. You can take the GATE as well as competitive program subscription, where for 1 year you will have 51,233. You may use my referral code like DEVALIVE. Right? So similarly, you can look at the plans as per your requirement. But the batch is already started, so be early to start. Here you will have so many different kind of live sessions are there. You can see C++, Python, Java, so many are there. And what are the advantages? You can see that what is a complete schedule for 28 weeks. The plan is very, very good, and you can follow this plan. And if you look at the educators who are going to train you for the placements, like you have so many people like Tanuj, Pulkit, and so many good educators are there. And you look at that, so many are going to join soon, and all these educators are helping you to understand the content which is required for placements. Yeah. Once again, good morning everyone, and please like the session if you have joined late. And let me begin my session. In this subject, we have completed set theory, which is important for us, propositional and predicate logic, and basics of graph theory, like what is a graph, right? What types of graphs are there? In that, what types of simple graphs we have seen in detail. And now today's session is about like connectivity that I was not covered in the previous session. So I'm covering in this one independent sets, covering and matching. So these three things I'm going to help you to understand. So let's begin with connectivity. In the connectivity, what are the definitions that I'm going to explain to understand? Like a component, what is component, and what is connected directed graph? How do you define the connected graphs in the directed graphs? And what is strongly connected component? And cut vertex, bridge, cut set, vertex cut set and edge cut set. And because of that, you can understand vertex connectivity and edge connectivity. And apart from this, we are going to look at the relation between the vertices, edges and components. Yeah, good morning Sandeep. So let's begin with the first one. What is the component? Sandeep, welcome. What is a component? Look at when you are talking about a graph, there are two types of graphs, connected graph and disconnected graph. If you look at the connected graph, we may not use the component word. The reason is this graph is having just one component. A graph with one component is called as connected graph. A graph with one component, that's all. Graph which has one component. When you have disconnected, not connected, when a graph is not connected, a graph with more than one component, then what is component? Very simple. Everyone, a graph which has more than one component is called as disconnected graph. Then what is component? Everybody? So we are using the component word to define the connected or disconnected graphs. Okay. Let's plan. What is connected? What is component? Let's plan to understand. Okay, I am having some graph. If you look at this graph, don't assume two graphs. There is a one graph. It is one graph. But is it connected or disconnected? It is connected or disconnected? It is disconnected graph. It is disconnected. How do you know it is disconnected graph? You can see that you have more than one component. Two components you have. That is two components. But what is component? Again, same point. Then what is component? Component is nothing but a subgraph. Remember, it is a subgraph. Not enough. It is a subgraph, but which is maximally connected. There are so many subgraphs in this graph. Even I can say AB is a subgraph. It is a subgraph. But is it maximally connected? No. No. Who is maximally connected? The subgraph which is maximally connected, you can see here, this is one component, this is another component. There are two components here. There are two components. Everybody, which is a subgraph, not enough, which is the maximally connected, is called as a component. Anybody is having a doubt? Let me know. Clear this point? Yeah. Now we have so many definitions on this component based. Let me look at. Okay, before coming to here, let's look at one more example. Okay, how many components are there? This is a one graph. This is a graph. How many components are there? Quick. Yes, can you see that? 4 components. 4 components. Yeah, if you know the definition of a tree, is it every component a tree? Every component, of course, no need to be. If every component is tree, then graph is called as, then such graph is, of course we know it is a disconnected graph, then such graph is, anybody? I'm leaving for you. If every component is a tree, then such graph is, quick, you might use such concept in many algorithms too. Is called as a forest. If every component is a tree, then such disconnected graph is called as a forest. Everybody? So many people have confusion between components, forest. So I'm trying to define the definition. If more than one component, it is disconnected graph. If every component is a tree, then that is a forest. Clear this point? Yeah. Okay, let's come to the connected directed graphs. There are 3 types of connected directed graphs. One is a strongly connected, and second is unilaterally connected, and third is weakly connected. So let's look at what is this connected graph. A strongly connected graph is connected graph, no doubt, but we are talking about directed graphs here. In the directed graphs, what is the relation between the vertices? For all vertices, let's say Vi and Vj belongs to the vertices of the graph. All vertices, every 2 vertices I am talking about. For all Vi and Vj, you will see a path from Vi to Vj. I am not talking about edge, path. And also there is a path from Vj to Vi. So path exists between every 2 vertices. Simply I can say path exists between every 2 vertices in both directions. In either directions. Sweta, just there is a path is not enough. There is a path. That path is both sides, x to y, y to x. Right? Just not a path. The path both sides is important. Example, very simple. You know, I have, let's say, I'm talking about directed, undirected. It's very easy to verify. We don't speak strongly, weakly in undirected graphs. In undirected, we have only 2 things, guys. Let me tell you. If it is undirected, we use only 2 words. Undirected graph, just say connected, disconnected. Just component is enough word. Connected graph, disconnected graph. That's enough. Connected graph means one component. That's the definition. Disconnected means at least 2 components. That's a greater than or equal to 2 components. That is a disconnected graph. More than one component. But if it is directed graph, we don't just say component. We say more than that. If it is directed graph, it can be connected or disconnected. Disconnected is very easy to understand. More than one component. You may say that. Connected graph, we have 3 types. Strongly and unilateral and weakly. Understand when to use these words. Yes, we use mainly in directed graphs. In directed graphs, we don't use undirected graphs. The strongly, unilateral and weakly words. Okay, now come to the point. A, B, C. Is it strongly connected? No, right? A and B, they have a path. A and C, they have a path, but only one direction. This is not strongly connected. Strongly connected in the sense. Look at another one. If I give this one, now look at the path exists between every two vertices in both directions. A to B, you have a path, and B to A also you have a path. And not only this, A to C you have a path, and C to A also you have a path. Not only this, you also check B to C you have a path, and C to B also you have a path. Between every two vertices, do you have a path in either direction? Clear this point? Now this is called as strongly connected. Strongly connected. Because I can show you a path between every two vertices in both directions. Clear this point? Everyone strongly connected. If I delete any edge of this, it will become not strongly connected. We can draw so many graphs like that, I can draw okay. You can see that this is also strongly connected. Yeah, Lavjit. Cycle exists, but every cycle you can't say now. Cycle graph, how can you say that? Cycle graph. Sometimes cycle graph not possible. Let me show you. I'm trying to contradict Lavjit's statement. Look at that. I form a cycle and I'm doing something here. Is it looks like a cycle? It's not a cycle, right? Yeah, more than a cycle, you have so many other edges. But look at this graph. You have a path between every two vertices. Yes or no? This is not a cycle graph. It's a cyclic graph, you can say. But cyclic doesn't mean, even I can delete this example. Is it strongly connected? It is a cyclic graph. The word Lavjit used is a cyclic graph. Cyclic graph it is. If you look at the second example, it is a cyclic graph. But is it strongly connected? No. Cyclic graph doesn't mean. See A and D. A to D you have a path. D to A you don't have a path. So be careful on answering. That is cyclic graph, no need to be strongly connected. Here the definition between every two vertices, not the structure of the graph. Between every two vertices there is a path from x to y and y to x if you assume x and y are vertices. Okay, let's go to the next one. Unilaterally connected. Here for all vi and vj that belongs to v is a set of vertices in the graph. Assume that always. Now you need to show just a path from vi to vj, or no need to be both. It can be both, is your choice. Vj to vi. The path exists from vi to vj or vj to vi. So that is enough to say unilaterally connected. And if you look at strongly connected, every strongly connected is unilaterally connected. Remember the word, because the path is there on both sides. That means you have either of them. Every strongly connected graph is unilaterally connected graph. Assume this is a UCG. Previous one, let me say SCG, strongly connected graph. Every SCG is UCG, but UCG need not be. Example. Look at this, A, B, C. This is unilaterally connected graph, but this is not a strongly connected graph. Everyone? Similarly, I can take an example. It is also not strongly connected because if you compare A and B, A to B there is a path, but B to A you don't have. It is not strongly connected, but it is unilaterally connected graph. You ask me any two vertices, definitely there is a path at least one direction. Yes or no? A to B there is a path here in the first graph, and B to C you have, and A to C you have. The relation between A and C we are looking at, B and C and A and B. You take any two vertices, path exists in at least one direction. Yeah, very easy example. Clear? Okay, next, a weakly connected. Here, first remember, every SCG is unilaterally connected graph and every UCG is a weakly connected graph. Indirectly every SCG is also weakly connected graph. Transitive property. But weakly connected graph, no need to be strongly, no need to be unilateral. So you need another example. What is the meaning of that? What is the meaning of that? If you are finding out two vertices, in the two vertices you will not find a path opposite of them. You will not find a path in any direction. Example, but don't say disconnected. We are talking about a connected graph. Suppose look at A, B and C. If you look at this graph, yeah. Okay, continue guys. Okay. Look at this graph. Is it strongly connected? Not strongly connected graph. Is it unilaterally connected? See A and C. A and C. Do you have a path in A to C or C to A? You don't have a path A to C or C to A. That's not unilaterally connected also. But if you remove the direction of the edge, is it connected at least? At least connected? If we make undirected graph, is that connected graph? That's enough to say it is weakly connected. So to say weakly connected, just it should be connected, that's all. It is weakly connected. How do you know that? Just remove the directions of edges. The graph is just connected. Clear this point? So no need to check any other property. Most of the graphs are connected. All the graphs are connected where there is no disconnection. If you have one component definitely connected, by default all the graphs are weakly connected. All the connected graphs by default weakly connected. If you look at the relation, all connected directed graphs are weakly connected graphs only. Weakly connected graphs only. But in which some of them are, you can also call them unilaterally connected graphs. And some of them you can call them as strongly connected graphs. But every strongly connected is unilaterally connected and weakly connected. Everybody? Come on. Please interact. Each minute try to say something so that I can understand. Do you have any doubt or not? Yeah. Clear? What are the connected graphs you have? Okay. Now, strongly connected component. We are talking about a strongly connected component. Strongly connected component. This is also, you need examples. अरे every connected graph यार, every connected graph देखना मत. Every connected graph, say that ना. Every connected graph is weakly. और क्या चाहिए आपको? इसका दिक्कत ही नहीं है. Weakly connected. देखना मत definition. Is it connected or not? Do you have, right? All the vertices are connected by somehow. All vertices are connected by somehow. Everybody? Weakly connected. All vertices are connected by somehow. Right? No need to have a path between A to C, but A and C are connected by B, that's fine. Every graph which has one component is weakly connected. Say that. You no need to apply the definition of weakly connected यार. दुनिया में जो भी connected graph है वो weakly connected by definition. आपको ये समझना है unilateral and strongly connected. Clear this point? इसमें definition ही जरूरत नहीं यार. No definition required for weakly connected. I am saying that if you make undirected Is it connected or not? That's all. Look at this. If we make undirected, means every edge we make undirected. If we make undirected graph, the graph is connected. Graph is connected. That graph is called as weakly connected. Over. So weakly connected. ये जरूरत है क्या चेक करना? डिफिकल्ट यहाँ पर स्ट्रांगली यूनिलेटरल उसको समझना. वीकली का डेफिनेशन नहीं है, उसको क्या समझ लोगे यार. राइट, वेरी इजी. एनी कनेक्टेड ग्राफ, आई एम सेइंग एनी कनेक्टेड ग्राफ इज वीकली. एवरी कनेक्टेड. प्रॉब्लम यहाँ होता यूनिलेटरल वीकली. वो प्रैक्टिस करना है तो कर लो. ये देखो ए बी सी, बाय डिफॉल्ट यू कैन से वीकली कनेक्टेड ग्राफ बिना देखकर. And is it strongly connected? No, because A and C, A to C path is there, but C to A you don't have. If you look at B, C, path दोनों side में नहीं है. Even it is not unilaterally connected graph. Why? If you look at B and C, you compare, B to C path not exist, and even C to B also not exist. इसका मतलब not unilateral. Unilateral में at least one path exists between every two vertices. Clear this point? Why it is not unilaterally connected? There are vertices in which the path doesn't exist in both directions. Clear this point? अगर आपको कुछ ऐसे वाले चाहिए, बहुत easy examples है वाले. इसको देखो, ये weakly connected blindly और unilaterally connected होगा भी. क्यों? You ask any two vertices, you will have a path at least one direction. But a strongly connected graph नहीं होता. Everybody? या आप पूछ सकते हैं यार, what is not weakly connected? पूछो, बताता हूँ. देखो, there are two components now. इसको बोलो not weakly connected. अगर वीकली कनेक्टेड ही नहीं है तो सब कुछ बेकार है. बाय डिफॉल्ट यू कैन से नॉट स्ट्रांगली कनेक्टेड ग्राफ, इवन नॉट यूनिलैटरली कनेक्टेड ग्राफ. है ना, इसको बोलते हैं बिकॉज दिस ग्राफ इवन यू मेक अनडायरेक्टेड इट इज डिसकनेक्टेड ग्राफ. मोर देन वन कंपोनेंट इज देयर. या फाइन. Strongly connected component. Let's focus on this. It is one of the important topic. Apply slowly. Strongly connected component. We will apply this definition inside the connected graph. Okay. In connected graph, we will try to apply this definition to find the number of strongly connected components. Okay. You have a connected graph. In that connected graph, you are looking for some components. Okay, now look at it is a subgraph. मतलब given graph is connected, in that you are looking for a subgraph. What kind of subgraph? Every two vertices are having path in both directions. वो तो है ना strongly connected graph की definition था. But ये पूरा graph में apply नहीं कर रहा है. We are not applying an whole graph. We are applying on some subgraph. But that subgraph is the maximal. So what kind of subgraph? Let's look at. Okay, look at this graph. Now you need to find out a subgraph. That subgraph as every two vertices path exists in both directions, and that subgraph should be maximal. Means by adding any other vertex, you should not satisfy the properties. So this is the property, every two vertices. Now look at what is the strongly connected component here. First let's say look at this 4. Look at this 4. But this 4 looks like subgraph. Looks like every two vertices there is a path in both directions, A, B, C, D. Do you agree or not? You ask me any two vertices in this subgraph, A to D, D to A to B, B to A, B to C, C to B. You have a path, but this is not a maximal. Who is the maximal? Who is the maximal? Anybody? Who is the maximal? This is a subgraph, but adding some other vertex also you are satisfying. And look at this one. Look at this one. Is it strongly connected component? Because this subgraph is the max. And every two vertices in this also they have a path. Clear this point? This is called as strongly connected component. What is the name of this strongly connected component? It is a subgraph, and now you cannot add any vertex to it to make another subgraph which can satisfy our property. This is our property. Assume that this is a property. And this property is not possible to satisfy by adding any more to this component. And this is the max subgraph in which two properties. There are so many subgraphs here, but we are looking for the subgraph which can satisfy our property, and that should be maximum subgraph. Maximal. Okay, another one. FG. Can I say FG? Is it possible to say FG is a strongly maximal subgraph or subgraph which satisfies our property? First, it is not satisfying our property. Why? Because F to G there is a path, but G to F you don't have a path. So it is not satisfying our property. So you can't choose that. You can't choose that. And F you add with anybody, it can't satisfy. So F is alone here. F is another strongly connected component. Everybody? Yes, total 3 strongly connected component. Good point. And another one, G and H, a maximal subgraph where it can satisfy our property. Exactly. Clear this point? Yes. They may ask you in the exam how many strongly connected components. This question is there. You can practice that now. You got here 3 strongly connected components. Clear this point? 3 strongly connected components. Now let's practice one question. Now find out, assume this is a vertex. How many components you have? How many strongly connected components? So that you will have a good practice. I hope you are able to see the graph clearly. And this is one of the important concept for the exam point of view. Numerical type gate question possible. Answer it based on your knowledge. Say the group of vertices so that I can understand which graph you are talking about, which subgraph. Yes, good point. Raj, A, B, C, D. And E, F, G, good point. Sachin, correct it. And H, J, you cannot mix with I. They are alone because only H to J, J to H, you have a path. But I, if you mix I to J, you have a path, but J to I, you don't have a path. And other one is alone. Total 4. We will answer total 4. 4 strongly connected components. Yeah, got the point? When you choose the maximum, it's a subgraph, but this is a maximal subgraph that satisfies the property. Yeah, very easy question once you know the definition. First, focus on what is component, then focus on what is strongly connected component, then focus on how to find them. Yeah, all will be easy, but if you go in a sequence. Okay, now let's move on to cut vertex. Very easy. Articulation point. You can also call cut point. You can also call cut point. So every vertex is called as a point. Cut node. Let's look at our path graph. Let's look at our path graph. Who is called as a cut vertex? Who is called as a cut vertex? Here, B is called as a cut vertex. Why? Not only B, you have a C also. Why is that? Why B is called as, also C is called as cut vertex? Why? But A and D are not cut vertex, are not cut vertices. Because if we delete a vertex, from graph, the graph will become disconnected. So mostly we will apply on connected graphs. If we delete a vertex from graph, the graph will be disconnected. So find out a vertex. If you delete a B, then graph will have A and CD, and CD will separate from A. Yeah, it's not just endpoints. Yeah, endpoints correct, but we will talk about the definition of a vertex. If you delete a vertex, the graph will become disconnected. Here only 2 vertices are possible, B and C. If you delete them, the graph will be disconnected. At a time only 1 vertex. Don't delete 2 vertices at a time. Be careful. And if you have a cycle graph, let's say cycle graph, tell me who is the cut vertex? Can you say any vertex is a cut vertex? No cut vertex here. The reason is, if I delete any vertex, the remaining vertices are actually connected because they are forming a path. So no cut vertex in any cycle graph, not only this cycle graph, any cycle graph, the cut vertex never exists. And if you look at these 2 questions, Raj, what is all? Here there is no cut vertex. Vertex is applicable to 1 vertex, not all. No cut vertex. By deleting any vertex, the graph we are not able to make disconnected. Okay, now look at the path graph. If there are n vertices, I am giving a path graph. Let's say this is a Pn is a path graph. If I ask path with n vertices, take n is big enough, let's say greater than 2, take it. Then tell me how many cut vertices in Pn. Everyone, how many cut vertices in Pn? Exactly n minus 2. Except endpoints, n minus 2 cut vertices. Every vertex other than the end vertex will act as a cut vertex. Everybody, every vertex other than the end vertices will act as a cut vertex. N minus 2 cut vertices. Yeah. If it is a cycle graph, how many cut vertices? No cut vertex. Okay. Now look at, you understood the cut vertex, right? Even similarly, I can say complete graph. Complete graph also not having any cut vertex. Yes, please try to understand the point. Okay, now look at the previous year gate question. The number of cut vertices in the following graph. Can you answer it quickly? This is a previous year gate question. Very, very easy. If you know the definition. Name them. If you find, name them. Look at this 2. If I delete this, then 4 will be separated from 1 and 3. And if you delete this, the 1, 2, 4 will be separated from 5, 7, 6. If you delete this, then 1, 2, 3, 4 will be separated from 6, 7. Yeah, you will have the 3 cut vertices, also called as articulation points. Yeah, 2, 3, 5. These are the cut vertices. 2, 3, 5 are cut vertices. Okay, now let's focus on bridge. You may say cut edge, but bridge, we have a name for that. What is a bridge? Look at a path graph. Let's look at a path graph. P, let's say 3. Can you see that? You delete any edge, it will become disconnected, right? By deleting an edge, if the graph will be disconnected, then that edge is called as a bridge. By deleting an edge, if graph is disconnected, then we can say, then such edge is bridge. Now, can I say every edge in a path graph, every edge in a path graph is a bridge? Delete any edge, somebody will be disconnected. Yes or no? Delete this edge, delete this edge. You delete any edge, somebody will be disconnected in the graph. And if there are n-1 edges, then n-1 bridges are there. Remember that. Every path graph will have n-1 edges, represent n-1 bridges here. Yes. Let's talk about cycle graph. Let's talk about cycle graph. Let's take C4. Do you have any bridge here? Do you have any bridge here? Cycle graph never contain a bridge. Cycle graph, no bridge. By deleting any edge, you are not able to make disconnected. Clear? No bridge here. Yeah. Similarly, if I ask, star graph, or if I ask complete graph, this is a K4, this is S5, star graph. Then look at here, do you have a cut vertex? 3 is called as cut vertex. For easy purpose, I am just using the edges, names E1, E2, E3, E4. And here, every edge is a bridge. If you delete any edge, the vertex will be separated from the graph. And here no cut vertex and no bridge, because it's a complete graph. You cannot make disconnected, because the complete graph definition is every two vertices are connected by an edge, not a path, just it is connected by an edge. They are adjacent. Here only one cut vertex is there in the center graph, in star graph. There is a center point. 3 is a cut vertex, but every edge is a bridge. There are 4 bridges and 1 cut vertex. If you want to talk about 1 cut vertex and 4 bridges are there. Okay, let's move. Randomly they may ask, so this is your graph. Now tell me the bridges. Vertices you understood easily, right? Let me name them: E1, E2, E3, E4, E5, E6. Tell me what are the bridges. Here you can't say every edge is a bridge. You need to be careful. Which edge I can delete? Suppose E4. If I delete E4, then ABC will be separated from DEF. Yes, E4. And E5 also. If you delete E5, then ABCD will be separated from EF. Even E6 also. So there are 3 bridges. Yes, 3 bridges are there. If I ask how many cut vertices, who is going to act as cut vertex here? Let me write that also. Cut vertex or articulation point. Cut vertex. Who is going to be cut vertex here? C is a cut vertex, because when you delete a C, AB will be separated from DEF, and D is also cut vertex, E also, but F is end point. You can't say that. Everyone, if you delete the F, remaining all are connected somehow. So here also 3 cut vertices. Right? Such questions are very easy in the exam. You can answer it. Okay, now vertex cut set. What is the difference between a vertex, what is that? Articulation point, that is cut vertex, and vertex cut set? Just looks confused words, but be careful. Cut vertex means we are talking about one vertex, and vertex cut set, it is talking about set of vertices. So definition is same. By deleting one vertex, the graph is disconnected, right? By deleting one vertex, that is a cut vertex, the graph always disconnected. If we delete cut vertex, one vertex only we delete. If we delete cut vertex, the graph is disconnected. Here if we delete this set of vertices, if we delete all vertices in cut set, then graph will be disconnected. Here we are not deleting one, we are deleting set. So let's practice on this. Suppose I have cycle. Let's say this one. Now you don't have a cut vertex, but you have a vertex cut set. You have a cut set. Right, you have a cut set. Tell me which vertices I should delete to make disconnected. I might have so many answers, like I can delete A comma D, I can delete even A comma B comma D, even I can delete just B comma D, or I can delete E comma B, or I can delete E comma B comma D, or I can delete let's say C comma A, or I can delete C comma A comma E, and this all are called as vertex cut set, because by deleting that vertices the graph definitely disconnected. You check it. Everyone, I can delete 2 or 3, don't delete 4 because only one vertex left. If AB is already a cut set, then you can say ABD also, because EC are still disconnected. And like you have many answers and find out all of them. This all are cut sets. And look at, if every cut set size is more than 1, that means you don't have a vertex, cut vertex. How do you know that cut vertex is not there? Because look at, every vertex cut set is more than one size. If you have a cut vertex now, you will have a set with just one vertex also. Okay, there is another one, edge cut set. What is edge cut set? Same, but now you focus on edges. So let me name edges. This is E1, E2, E3, E4, E5. Now look at who is edge cut. I can say E1, E2, or I can say E1, E2. When I delete, the vertex B is gonna be disconnected, and I can delete E1, E5, and basically so many cuts. I can do this cut, or I can do this cut, or I can do this cut. You have so many cuts here. Not only that, you can do this way, and look at that line connecting the edges, you can delete them. E1, E4 also you can delete, and E2, E3 also you can delete, and so many, like I didn't make all cuts. E2, E5 also you can do, and still I can do lot. E3, E4, and E4, E5, and with 3 also you can do, I think, E1, E2, E3. So many are disconnected. E1, E5, E4, and you can delete all the edges. That is a trivial. That is a trivial. You can delete all the edges. Graph definitely disconnected. Yeah. Sandeep, there might be theorems which will talk about depends on the graph. Sandeep, you might have a relation depends on the graph. Maybe you can try for cycle graph, star graph, complete graph. Relations definitely possible sometimes, Sandeep. And graph to graph, the relations will change. This is cycle graph where you can look at that every 2 edges, at least 2 edges you make it, then graph will be disconnected. Yes or no? There is all the sets which are having more than one size will be edge cut sets. Can I say directly? Why do you want to delete this to that too? Clear? But carefully delete while, can I say all word that I am looking at it? Can I say all? Everyone? Right? Yeah. It will break the cycle. If you delete 2 edges in the graph, it will break the cycle. Okay, now vertex connectivity. Look at, and I am asking about what is the smallest vertex cut set. What is the smallest vertex cut set? You have so many vertex cut sets. Maybe here I can say, like, E is a one vertex set, and I can already E is there, so I can keep E comma B, I can keep E comma A, or I can keep E comma D, or I can keep E comma C. Even all of them are cut sets, because E was already making disconnected, by deleting this, don't delete more than 3 vertices. So many are there. Who is the smallest vertex cut set? E. And what is the size of E? That is a 1. So this graph is called as one vertex connected. The 1 is called as the size of smallest vertex cut set. Clear? Why we say one vertex connected? You can try like this. If you have a cycle graph, this is a C4, and how many vertices minimum I should delete to make it disconnected? Any cycle graph you take, minimum 2 vertices, like I can delete A comma C here or B comma D. Both are smallest only. What is the size of the smallest? 2. So you can say 2 vertex connected. I can say every cycle graph will have such things. Even I take C5. Here also I can delete B comma D or A comma D, something like that. C comma E. Of course 3 vertices also you can delete. Even A, B or D. Like so many. Who is the smallest? Size 2. So it is also 2 vertex connected. Right? Every cycle graph is 2 vertex connected. Every cycle graph. Such questions may be asked in the exam. Then you should be careful. Okay, what about edges? Now I am talking about edge. What is edge connectivity? Now what is the smallest edge cut set? You need to find out now smallest edge cut set. So I am naming them to use clearly, E1, E2, E3. Delete any edge is enough, right? E1, E2, E3. These are the smallest. But you have so many other, like, but they are not smallest. E1, E2 you can delete, E1, E3 also you can delete, and you can go for deletion of all of them. But who is the smallest edge cut set? These 3. And what is the size? 1. So we say that one edge connected graph. And this 1 represent the size of smallest edge cut set. So finding the smallest edge cut set is the first job, then finding the size later. Everyone? Okay. And there are many concepts here. I do not know how to cover them, but I will try to cover at least in practice session, where you know how to find the number of components when you delete a vertex or delete an edge, and how many number of edges in a connected graph and disconnected graphs. All such relations are there. Okay, I just ignore them, but I believe that you might practice. I'm going for 3 important topics where which will help you to solve some questions. Okay, can I go to the new topic? By leaving so many important topics, but I have covered much important ones. Independent set are 2 types. One is vertex independent set other one is edge independent set. What is vertex independent set? It's nothing but set of vertices where every two vertices in the set are non-adjacent. They are not connected by any edge. Edge independent set also similar. It is set of edges where every two edges are non-adjacent. Clear? Then let's practice this too. Okay, let's practice this. Okay, there is a graph. And I'm also naming to understand edges. If you don't name them, it takes time. To represent edge A comma B, B comma C, you need to do a lot. Okay, now who is a vertex independent set? I'm just writing two things here. Vertex independent sets other side edge independent set, EIS. Here you can say VIS. Okay, vertex. Can you tell me vertex independent set? By default, every vertex is independent. If you have only one, it's a trivial. It is a trivial. If a set has one vertex, by default it is vertex independent set because you don't have two vertices to compare. If you have two vertices, see, if I write A comma B, you should say no because A and B are adjacent. If you write A comma C, yes, you have to say. By default, one vertex is what? Independent set. But when you have two vertices, you should check, are these two adjacent or non-adjacent? If they are adjacent, not independent. If they are non-adjacent, then independent. Then similarly, A comma D. Similarly, A comma E. If I ask B comma C, you should say no because B and C are adjacent. But you have to say B comma D. And B comma E, yes. And what about C comma D? No. C comma E, yes. But three vertices also possible sometimes like A comma C comma E. You have to say yes. A, C, E, all are non-adjacent. Everybody agree? Even three vertices are also possible in the set. But four vertices don't keep because somebody comes for adjacent to somebody. Yeah, guys, please like the session. If you have joined late and you forgot to like, please do that. Okay. And you forgot to write three vertices. Yes, three vertices also there. ACE. Now, edge independent sets. What is edge independent set? Guys, what is edge independent set? Now edges, not a vertices, focus on edges. E1, E2, individually, they are always independent. One edge is by default. Now when it comes to two edges, try for two edges. E1 comma E2, no. It's not independent set. E1, E3, yes. And E1, E4, yes, because they are not adjacent. And when it comes to E2, E1 already checked, I think, the first one. And E2, E3, no, because they are adjacent. But E2, E4, yes. And E3, E4, though not. And take three edges, definitely, they never be independent set. Who is that? Sandeep. Three vertices, yaar. A, C, E, A, C, E, they are all non-adjacent, right? And what is the definition of the independent set? If you keep the set of vertices, every two vertices must be non-adjacent. Do you agree or not? That is the definition, right? Every two vertices in that set should be non-adjacent. That's why ACE is independent set, because every two vertices in that set are non-adjacent. Is that clear? Yeah, that's why we kept 3. We are not able to keep 4. If you keep 4, definitely somebody comes, because only 5 vertices. Look at that. Try to keep any 4. Any 4. Definitely somebody will be adjacent to someone. I'm not able to write 4. Try it, write it. You will fail. A, B, C, D. A, B to already adjacent hai, so why can you say, you cannot say it's the independent set. At least 2 vertices that you will find adjacent if you write more than 3 vertices. Okay, chalo. And now, अब आएंगे. अब एक second, I need to copy this. Okay. Now the same problem, I'm just writing. Find a maximal, one word is coming, maximal vertex independent set. You need to keep set of vertices where addition of a vertex is not possible. Example, if I keep A, comma, C, comma, E, is it possible to add any vertex to it to make another independent set? Is it possible to add B or D to this set? It is already independent set. Now can you add any vertex to it? It's not possible. That's why it's called maximal. So what is the definition of maximal? Maximal, VIS. There is another one, maximum. We'll see later. Maximum is different. Maximal means it is vertex independent set where addition of any other vertex it will be no more. It will not be VIS. It will become, you can say. That means there is no more VIS by adding another vertex. Yeah. Maximum means largest vertex independent set. Both are different, guys. Largest is different, maximal is different. Let's look at maximal. There is another maximal, B comma D. Now look at B comma D. Add any vertex to this, it will fail to become VIS. Yes or no? Quick. B comma D. Try to add A, it is adjacent to B. Try to add C, it is adjacent to B and D. Try to add E, then E is adjacent to D. Then B comma D is also maximal. Understood? But V is maximum. This is called as maximum. Largest. Largest. Everybody, there are 2 maximals. In the exam, maximum is important because there is called as vertex independent number. Vertex independent number. If you want to understand vertex independent number, you just need largest one, that's all. You don't need maximal word. Vertex independent number is nothing but size of largest VIS. Then who is the largest? That is the 3. So vertex independent number is the 3 for this given graph. In the exam, they may ask you find the independent number for the given graph. Okay, then vertex independent number you should answer as a 3. But what is edge independent? You have to try. And first let's see maximal. Maximal edge independent sets. Maximal. So try E1, E4. Is it maximal? Yes. And E2, E4, it is maximal because you can't add any more edge. E1, E3, E1, E2, anyhow it's not possible. Anything else? Anything else which are possible? All are having same size, so all you can say maximum because size is 2 for everybody. If you have 1, 2, 3, then you can say 3 is the maximum. And one size is there possible, but that is not a maximal. You can write E1, but this is not a maximal. Why? Still you can add E3, you can make another independent set, right? So these are maximals and all are maximum too here because same size. If they are same size, all are largest. So here edge independent number is nothing but size of largest edge independent set, which is here 2. Sandeep, all are maximum. Should not say no maximum. All are maximum. Okay. And look at here, the maximum, no need to be one set. You could have more than one set which are largest. Now let's practice for some examples. Okay. Okay, look at this. These are vertices. Okay, now I'm finding what is largest vertex independent set. And maximal word may not be important for gate, but largest is important. What could be the largest size you can write? Let's try. Possibly independent, right? Let's start with A. Next, B you can't keep, but you can keep E. And if you keep A comma E, you can't keep any more. You can't keep any more. Everyone? But it is not a largest. The reason is I can still have C, D, F, A. And 4 vertices I can have. So this is possible largest. But look at total, you have 6 vertices, among them 4. Is it possible to have 5 vertices? Is it possible to have 5 vertices? Quick. Not possible. This is the largest. And try to make the bigger one. Don't try any other independent set with 2 vertices because already you got a 4. Now try for 5. There is no independent set with 5 vertices. So what you can say? Vertex independent number is 4. Yes, we concluded not possible with 5. That is the reason we stopped at 4. Otherwise we should have taken 5 also. Not possible with 5 vertices. Okay, similarly, edge. I want largest edge independent set. Now try to have, first let's say E1, E5. You got a 2. Now try for 3, 4, 5. Is there any possibility of 3 edges? Try guys. Don't try 2 edges. 2 already we got it. Try with 3 edges. Is it possible? If you take E5, 3 edges are adjacent to E5. Right. Any other? If you try, you will get again 2 only. You can try that. If you take E3, again you get E1. E1, E3. And E4, E1. If you take E2, of course 1 you should never try. Everybody is adjacent. Now more than 2 not possible. So this is edge independent number is 2 only. Only 2 edges, because with 3 edges not possible. In the exam you should try 1. I know if you get a 2, don't try 2 again. Try for the 3. If you get a 3, try for 4, so that you can stop quickly in the exam. Yes. Yeah. Clear everyone? Okay. Now we have one more topic that I will be covering tomorrow session, covering sets and matching. The 2 topics left today. So I'll be taking tomorrow, guys. Today I'll help you to understand connectivity and independent set. So tomorrow we will be seeing along with other topics covering set as well as matching. Yeah. So see you tomorrow then. If you are enjoying our sessions and you are seriously preparing for GATE, and you might be thinking that you want to learn systematically every concept, and definitely we are there in Plus and we will help you. And you will be seeing more faces who are gonna be joining soon. As I'm talking about, you will have tomorrow's surprise on RBR channel, so you can watch the tomorrow launching event today or tomorrow. So use the code DEVALIVE to join the batch. And plus you have very good courses and structured courses and iconic. Additional to them, you will have a personal coach and dedicated coach we have for every student who is taking iconic subscription. And you will also have a study material separately, and you will have a separate study plan and so many benefits. Yeah. And you have Plus subscription. If you are looking at prices and you are not aware of these prices, in case if you want to know about, please watch this slide. And similarly for iconic also, you have a different price for 1 year and 2 years. If you are going to take the subscription, you may use my referral code. Yeah, this is my profile to follow my classes on Unacademy. And I think today you have a class at 3 p.m. algorithm revision. If you want to attend, you may attend on Unacademy special class, which is a free class, and 3 p.m. and you have many classes too. Yeah, this is our Telegram channel where you can subscribe to get daily notifications from us. And we have many good YouTube channels from Unacademy. And in case if you have any friends, please share with them so they will also get benefit. And please like the session if you have not done it, and please share and subscribe. And thank you so much everyone joining this session, and see you in the next class tomorrow 8:45. And today we have another educator launch today on this channel and we will have 2 separate special sessions today. We'll all come together on live in one session, and other session we have one educator launch on this channel too. Yeah, thank you so much. Bye bye. Take care. Yeah, thank you, Lavjit. Bye bye. No, Raj, we don't have any scholarship program, I think, but if you apply to the Combat, you may get 1 to 3 months free subscription if you get the top